worksheet you picked up when you walked in and a highlighter. Okay, I need you to pay attention. You're going to have some new vocabulary. This is pretty much the last thing you have to know for trig. Okay, we're about done with the unit. We're going to start practicing using trig to solve word problems, okay, and to solve real-world scenarios. Now, we're going to need to know angle of elevation and depression in order to do that. I'm giving you the definition for angle of elevation. It's the angle formed by the horizontal line, and we all agree from our test yesterday and looking at that this is a horizontal line. Yes? Is this a horizontal line? No. Okay, good. All right, so the angle of elevation is formed by the horizontal line and the line of sight of an object above the line. So if I'm looking up above the line, that's elevation. Okay, that pretty much makes sense. So angle of depression is formed by a horizontal line and the side of an object below the horizontal line. Okay, elevation is above the horizontal line. Depression is below the horizontal line. All right. So the first thing or the first skill that you have to make sure you know is to identify the correct angle. Make sure you can decipher between if it's an elevation, angle of elevation, or an angle of depression. So if we look at this example right here, the dotted line are your horizontal lines. This arrow is pointing to angle B. Is angle B an angle of elevation or depression? Elevation or depression? Here's the horizontal line. This angle is below the horizontal line. So this would be angle of depression. Okay? Make sure you know why. Okay? Make sure you know why. So this is because the angle is below the horizontal. Okay? Yes. It's always going to use the horizontal line for elevation or depression. You see how this is a dotted line? You would create a horizontal line so it meets at the transversal, at the hypotenuse. So like if it's not drawn for you, you're going to draw the horizontal line and make sure that the angle is below or above that line. Yes. The angle's on the line. You have to use the horizontal line to form the angle. All right. Angle A would be the angle of elevation because the angle is formed with the segment AB and the horizontal line, and that angle is above the horizontal line. Does that make sense? Okay. All right. Now, what is the relationship between the horizontal lines? All horizontal lines are what? Parallel. Okay. So these two lines are always parallel. The horizontal lines are parallel. So what do we call the line AB? Yep. This line right here is your transversal. I'm just referring to what we did last semester because if I look at angle B and angle A, they have a relationship to each other. So since the lines are parallel, the horizontal lines are parallel, therefore the relationship between the angle of elevation and the angle of depression is what? Not perpendicular. No. Not skewed. How do we know they're congruent, Mountain? Yes. Therefore, the angle of elevation is congruent to the angle of depression. Because they're alternate interior angles. You need to understand that because if I ask for the angle of elevation, but I draw the angle of depression, you have to know that they are the same. Okay, so I can rearrange my drawing and use the angle of elevation instead of the angle of depression because they are equal to each other. Always going to be equal. All right, so the first thing, the key part to being able to set up the problem right is make sure you identify the correct angle of elevation and depression. So using this little picture here in this scenario, angle 1 is an angle of what? Depression. How do I know it's depression? Yeah, below the horizontal line. It would be the angle of depression from blank to blank. Yeah, plane to the tower. Okay? It would be the angle of depression from the plane going down to throwing a signal to the tower. Does that make sense? Now, angle 4 would be an angle of what? Yeah, that would be an angle of elevation. All right. That would be the angle of elevation from blank to blank. Yeah, from the man to the tower. Okay? So, I know there right now, we're just looking at this angle of depression and angle 4 is angle of elevation, but there's more than one angle there, okay? So, which angles would be congruent to each other? Yeah, angle 1 would be congruent to angle 2, and angle 3 would be congruent to angle 4.
So angle 1
No. Why can angle 1 not be congruent to angle 4? Different transversal. Okay? Different transversal. Yes, horizontal lines, but they have different transversal. And that's important too. Are we good understanding? It has to have, they are congruent when they have the same transversal. Okay? Here, we don't have the same transversal. All right. All right, so flip it over. Now we're going to go straight to our practice. All right. Says the angle of depression from the top of an 80-foot building to point A on the ground is 42 degrees. How far is the foot of the building from point A? They went ahead and labeled the scenario for you. We're going to have sometimes when the picture is given and sometimes when it's not. And we got to know how to do both ways. Now, my question to you is, you see how they told you where the angle of depression is? Okay? And then they put the 42 with the ground. Did it matter where I put the angle? No, because we know, you should also know, always know, that the elevation, the angle of elevation, is equal to the angle of depression when they have the same transversal. Okay, so these two have the same transversal. Now, I'm going to highlight this part because I want you to see what is used to solve a problem. Look at from B to A to C. That is a triangle, correct? What type of triangle is it? It is definitely right because horizontal line, and the distance between two parallel lines, because horizontal is parallel, is always perpendicular. In order to have parallel lines, the distance between them is always perpendicular. Okay? So, I got a right triangle. You're going to have some type of right triangle. You're going to have to draw or create some type of right triangle to do the trig and the word problems. So, here's your angle, 42 degrees, 80 feet. is opposite in relationship to that angle. The x is adjacent in relationship to that angle. We have tangent. So now we know a trig function, so we're going to use that trig function to solve for x. The tangent of 42 equals opposite, which is 80, over x. What do we do when x is on the bottom? Divide. We're going to have to switch these two, and I'm just going to rewrite it. X is equal to 80 divided by the tangent of 42. This is what we put in our calculator. When you do not have a calculator, you need to at least get it to calculator ready so you can use it in class. But we're basically going to type 80 divided by the tangent 42. And we're going to round to the nearest 10. Or did it say? I can't remember. It didn't say. Okay, we're going to round to the nearest 10. 88.8. So x is approximately 88.8. Yeah, it's always an approximation. Yeah. Huh? Approximately? Yeah. Okay. Number 2. A surveyor stands 200 feet from a building to measure its height with a 5 feet tall theodolite. Y'all know what a surveyor is? Have you ever seen someone like surveying the line? It looks like a tripod. They're looking through it. And they're surveying the line right before a construction site. Okay. Usually when they do that, they're kind of trying to make sure that the the landscape they're going to use and the measurements that they're going to use are going to meet code. You got to be so many feet from a power line, so many feet from a water line, okay? And so they use that to kind of scale out and make sure they're going to be within basically code. Right, so we have this machine, kind of looks like a little tripod that they use to survey the land. And it's going to, we're trying to determine that, oh, the angle of elevation from that surveyor to the building is 80 to 35 degrees. So it's going to go up. It's got to be with the horizontal. Angle elevation is above the horizontal line. So that's 35 degrees, excuse me. No, I'm running out of room right here. And that machine is 200 feet away from the building. Now, this is basically where my building is. Everyone agree? It's not Picasso, but somewhere around here. All right. Thank you. All right, so we're trying to figure out the height of the building, but they give us the height of a theodolite. So this is 5 feet right there. So we need the whole building, but I know I could find this vertical distance in my right triangle. To get the whole building, though, what are we eventually going to have to do? Add the 5 feet, okay? First, we want to just find the vertical distance in the right triangle using trig. So here's my angle. I got opposite and adjacent. So that's tangent. Yep. So I have the tangent of 35 degrees equals x over 200. And so x is on the top. So to solve it, I'm just going to do 200 times the tangent of 35. So do that for me. So x is approximately 140. Alright, so the building, though, the building would be 145, right? Because you would add the 5 feet from our surveyor. Are we good on that? Are we okay on that? Because this distance is only from here up. We're measuring it from 5 feet above the ground. So we still gotta add the 5 feet to the ground. Alright. Number 3. An airplane flying 300 Oh, 3,500 feet above ground begins a 2-degree descent to land at an airport. How many miles from the airport is the airplane when it starts its descent? So think about it. We got the plane. We got to figure out the drawing. What will we do? All right, from the plane to the angle, we need the 2 degrees. All right, so this is what I was saying. There's not really a horizontal line, right? That angle of descent would be representing from the horizontal to our descent to that transversal coming down. The vertical distance, the distance to the ground, is what? My drawing is horrible. 3,500, yeah. So if it's 2 degrees as an angle of descent, the 2 could also go where? Here. Because these are alternate interior. Are we good on that? Your airport, somewhere over here. We're trying to figure out how far. You mean here?
Yes.
No. Because an angle of depression, descent is descending down, right? It's always with the horizontal line. So this angle here is with the vertical line. So it has to be with the. I know there's not a horizontal line, but your line of sight is from the horizontal down. Okay, that's a good question. All right, we got the angle. We're trying to figure out the distance. So hopefully we see we have opposite. We also have adjacent. What trig function we're going to use here? Tangent. Okay. Tangent of the 2 degrees equals 3,500 over x. We need to switch them, so x is going to equal to 3,500 over tangent of 2 degrees. Wait, in regards to what? Yeah, it does matter. Yes, yes. The number has to come on top. You're dividing by the tangent. If you do it the other way, you're dividing by the number. So it does. Yeah. What you get? Hmm? No, didn't you get that? Oh, what'd you do after that? Uh-huh. You got this. It's there. Then what did you do after that? I'll agree that this is feet. And I know they're asking how many miles. What are we going to have to do now? Yeah. Okay. That's what you're trying to do, okay? Are we okay on that? How many feet in a mile? 5,000. Yeah, he's right. 5,280. Yeah. Hmm. We know there's 5,280 feet in a mile. I have 100,227 feet. So all I'm going to do is now take that and divide it by to figure out how many miles we got. Okay? It's like approximately like 18. What is it? 18 point what? So approximately 19. Okay. Are we okay on that? All right. So we're good. I need you to now go to your homework packet, which I believe this is your. No. Yes. Oh, yeah. Switch your homework packet. Oh, we already did that. No, so that's what I'm saying. On your homework, that's what we're going to get to. Oh, your homework is this page 9, 10, 11, and 12, even. Okay. I want to talk about, yes, I want to talk about page 11 first. All right, so let's look at number 4, because mine already has it. He started on this, which is a good thing. All right. Since from the top of the lighthouse is 210 feet high, the angle of depression of a boat is 27 degrees. Find the distance from the boat to the foot of the lighthouse. The lighthouse was built at sea level. So, see how you got your little boat here? We know from here to here, the top. Boom. You're going to have some type of right triangle to do these problems. Yeah, the angle is always with the horizontal. So this would be the 27 degrees. I know it says angle of depression, but we should know that the angle of depression is also equal to the angle of elevation. It's always with the horizontal. We know that the lighthouse is 210. We're trying to find the distance the boat is from the lighthouse. That's the horizontal. Okay? So in your drawing, you're going to always use the right triangle, and then you're going to label the parts to match the scenario. So we have opposite and adjacent. So this is tangent. So tangent 27 equals 210 divided by or over x. X is on the bottom. So all I'm really going to do is just switch these two around, rewrite it. X is equal to the 210 divided by the tangent of 27. And that will be our answer. Is that okay? All right. I think it says to the nearest tenth. Yeah. It's the nearest tenth. And if it's nearest angle degree, that's really just whole number. All right, so let's look at 6 then. An airplane rises vertically 1,000 feet over a horizontal distance of 5,280 feet. So I know there's no picture. Just get used to making sure that the picture that you draw is some type of right triangle. Always use the right triangles. We know the vertical is 1,000 feet. The horizontal is 5,280 feet. What is the angle of elevation of the airplane's path? Okay, we're using tangent again, but now what are we going to do? Because we're trying to find the angle. We're going to use the inverse. So x is the tan inverse of 1,000 over 5,280 to get the angle of elevation. So if no picture is drawn for you, what type of picture you're going to have to draw? A right triangle. Okay? Get in the habit of drawing a right triangle and then labeling it based on the given information in the scenario. Okay? So like on number 8, angle of elevation from a car to the tower. We're going to use the right triangle. Elevations, the horizontal and the hypotenuse. The tower is 150 feet tall. How far is the car from the tower? You're going to start seeing a pattern here. Sometimes, but there's going to be times where you don't. So like, let me show you real quick. I think it's on elevation and depression are equal to each other. Well, yeah, when you're trying to find the elevation, you're doing the trig inverse. Yeah. Like, so on number 12, your right triangle is here. Okay. This is your 70. We want to know x. So this one's not going to be tangent because you have the hypotenuse. Okay. So you got to go based on what's labeled and what's given to you. All right. So homework is posted. We're checking it tomorrow.